Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we will derive an equation for the force exerted by the jet on the inclined plate moving in the direction of jet. So we need to find out the force exerted by the jet on the inclined plate which is in moving condition in the direction of jet. Okay, so uh, up to now we have discussed regarding the stationary plate, and in the last lecture we have discussed about the moving plate when the plate is condition is vertical. Now the plate condition is inclined. Okay, so let consider a plate is there. Suppose this is the plate which is not fixed, which is supposed to be moved after striking the jet. So this plate we can keep here. So this is the plate, and the jet of water which is striking the plate, so that's supposed to come out from a pipe. Okay, so basically the application of this concept will be like in the turbine cases. If you see turbine cases, many of the turbine having the application of this impact of jets on the turbine blades, or the blades or vanes already we have discussed previously. So suppose this is the pipe is there, and from this pipe there is a nozzle connection is there from this pipe, and the jet of fluid which is coming out from this pipe of with a velocity of v. So this is the pipe diameter, and this is the diameter of the jet. Okay, and the jet which is coming out from this pipe with a velocity of v, and that is going to strike to a plate here. Okay, now we can see, though when the plate was fixed, then we can see the impact of jets after striking here. The jet of fluid supposed to goes out from this both side. Okay, and though the plate is inclined to the jet of the fluid, so inclination angle is taken theta, and the plate after striking here, the plate started moving with a velocity of small u, and it's moved some distance from initial position to some final position, some distance it moved. And after striking here, the jet after striking the jet on the plate started moving with a velocity of u, and here the movement of this, you can see the movement of this is considered the relative velocity, not the velocity of the jet or others. So here we need to consider the concept of relative velocity, what I have told you previously also. Okay, so before going to derivation part, let's see what are the parameters need to be considered here. First one, we can see the v. V is the here now absolute velocity. Here this is absolute velocity of the jet of water. This is absolute velocity of jet of water. This is first one. Second one, we can consider the small u. So the small u is nothing but the velocity of the plate in the direction of jet. So this is only velocity you can consider. Velocity of plate. This is the velocity of plate in the direction of jet. In which direction the jet is moving, the same direction we need to consider. As I told you, this jet is moving in this direction, so the plate also will started moving in this same direction, but the plate is inclined condition. Okay, now next is t. We need to consider, this is diameter of the jet, and similarly we can find out from this diameter of the jet, we can calculate the cross sectional area. So next is the cross sectional area of jet. So unit also we can write here, velocity of the jet, this is meter per second. Similarly, this is also velocity of the plate, meter per second. Diameter of the jet, this is diameter, it is, we can consider meter, and here a cross sectional area, this is meter square, and the formula we know that this can be calculated as pi d square by 4. So this area can be calculated pi d square by 4. And next one, the theta, the angle between the jet and plate. The angle made between the plate and jet. Angle made between plate and jet. So these are the parameters we need to consider here. Now, as I told you, we need to consider the relative velocity of the jet of water, because initially this velocity was jet of water we used to consider when the plate was fixed, and after striking this one we used to get a velocity at this point 0, and here though the plate started moving, that means jet of the fluid also moving, the plate also moving. So that's why this v we have considered this is absolute velocity, and the velocity of this plate taken u. Now we need to find out the relative velocity. Now the relative velocity of the jet of water. This is relative velocity of jet of water, So how to find out this relative velocity of the jet of water? So this is actually, suppose if you consider like one vehicle is moving in this direction and another vehicle also moving in the same direction. So this vehicle, suppose V1 is moving with a velocity of 40 meter per second. Let's consider this velocity of this vehicle is 40 meter per second, and the second vehicle velocity is suppose 20 meter per second. Now, if it is only single velocity is moving, then we can say the velocity of the vehicle is 40 meter per second. Now, another vehicle is moving, P2. Now, if you find out the relative velocity of the V1, okay, because see, we cannot calculate the relative velocity for the V2 because it is moving with a velocity of 20. Now, if you want to calculate this, another vehicle need to be compared. So, here the relative velocity we need to consider, or relative velocity of V1 we need to calculate. So, relative velocity of the V1 equal to what is the velocity of the V1 minus what is the velocity of V2. So, then we can calculate the relative velocity equal to 20 meter per second. So, similarly, here you can see the jet is moving in this direction, the plate also moving in the same direction. This is the plate which is moving in the same direction. So, now the velocity we need to consider here, that is called relative velocity. So that's why the relative velocity of the jet of water with respect to plate, that we can also consider here. This one also we can write, this is with respect to the plate. We need to compare with someone, then we can find out the relative velocity. So this is nothing but the absolute velocity minus the velocity of the plate. This is actually relative velocity of the jet of water. Okay, I hope you understood. So the same thing also we have discussed in our last lecture also. Now we need to find out the velocity of the jet which strikes. So this is nothing but the velocity of the jet which strikes this plate. So this also we can write the velocity with which we can write the jet strikes. At what velocity the jet strikes? Now we can consider the jet strikes the plate with a velocity of v minus u. So here if you see, the same v minus u need to be considered, and after striking here, the velocity of this fluid which will come out from this plate also v minus u. Okay, now when it is possible, now when the plate is smooth, when this plate is considered when plate is smooth, then we can say, when the plate is smooth condition, then we can say that the loss of energy due to this impact of jet is totally zero. So the loss of energy, you can consider loss of energy due to the impact of jet on the plate is equal to 0 because of what velocity was striked here. So what velocity striked here? V minus u. Okay, the same velocity of the fluid came out from this plate. Okay, that is the only difference here. So the relative velocity we need to consider here. Okay, now and next one what we can write? So this v minus u, that what is strikes it, the same velocity came out here. Now we need to find out the mass of water. The next step is nothing but the mass of water. The mass of water that's striking per second. Striking per second. So this one already we have calculated previously, the mass of water striking per second. So this is nothing but actually we know that rho a v. So rho a v velocity, what, which velocity? We know that this is the formula actually. But what about the velocity? Now the velocity we have taken here, we have considered here, that is relative velocity. So that is rho a v minus u. So how you got the rho AV? If you ask this one, that this also we have done many times in previous equations. So that is nothing but mass. This is mass of water per second. Okay. So this is mass per, this is nothing but mass flow rate. We can also consider. Now this mass one, I can write rho into volume, because I know that rho equal to mass by volume. So mass equal to rho into volume. This is with respect to time. So this is second. So this is volume per second. This volume per second is nothing but we can say this is a discharge. Okay, unit of discharge, that is meter cube per second. So rho into this discharge. So you can write again this one rho into Q. And this Q discharge, as I told you, that also you can write rho into A into V, because discharge A Q equal to area into velocity. In this way also we can frame it. Okay. Even unit wise also, if you want to consider that, also you can take it. So this is about the mass of water striking per second. Okay. Now we need to find what is our intention? We need to find out actually what is our intention. We need to find out the force exerted. We need to find out the force exerted by the jet of water, on an inclined plate, and which is in moving condition. Let me write this one in bracket, that in moving condition. Now see, the force exerted by the jet of water on an inclined plate in moving condition, in which direction? In the direction of jet. So here I can write in the direction of jet. So that means what? It means we need to find out the value of force in the x direction, So at what direction the fluid is moving, in this direction we need to find out the force. Okay. So now we need to find out the value of Fx, and similarly also we can find out the value of Fy. Okay. Now, but here if you see, the plate is inclined condition. Let me draw the plate here. I hope you understand. This is the direction of jet. I have just given in the XX line, suppose. And here, let the plate inclination here. This is the plate inclination, and the plate inclined here with an angle of, this is theta, with an angle of theta. If this is theta, this side also we can consider this is theta. Correct. Now here, though we can see the plate is in inclined condition and is in moving condition also, moving situation also. So moving situation, we have identified the relative velocity can be considered here. So the velocity of this fluid at this point, we can consider this is nothing but v minus u. Okay, at this velocity it is striking here. But what is our intention? We need to find out the force in this direction. That means we need to find out the Fx. Okay, but Fx equal, actually what is the formula of Fx? We know, or a normal F equal to, like how to find out the value of F. We know that if I write here, we know that F equal to, this is mass into acceleration as per the Newton's second law of motion, or impulse momentum also, equation also you can write the rate of change of momentum. Somewhere it will be written mass into acceleration, somewhere it will be written like impulse momentum equation, and there we can write this is the mass striking per second with respect to change in velocity. So this one again I can write this one mass into acceleration. Acceleration equal to what? That is velocity with respect to time. So change in velocity with respect to time, that is nothing but dv by dt. So dv by dt, again I can write this is mass into, this is dv by dt, what? v1 minus v2. What is v1? The initial velocity of the jet and final velocity of the jet, because impact of jet on the plate. So jet velocity initially and minus final velocity of the jet on after striking with respect to t2 minus t1. T2 minus T1. So this one again, what I'll write here, this mass per second, this one, this is nothing but mass flow rate, what we have calculated here, mass per second, and this is change in velocity, this one V1 minus V2. So normally if I want to calculate this, normally just I'm writing here, if I want to find out if, so what I can write here, this is mass striking per second, just I'm writing short form, in bracket I can write here, this is V1 minus V2. Okay, I hope you understand. So this one we know, up to now we have done many things, so there we have discussed already. But here if you see the force here, what is there, the force it's striking this one with respect to some angle. So first of all, what we need to find out, let's consider a force which is striking this plate with respect to normal, but here it is angle is there, theta angle is there, not normal. So we need to consider a force, a impact of force on this plate which is acting here with normally. So the force of, okay, which is acting here normally. So this is the Fn, and that one we can consider, suppose this is the n direction. So this force is acting in the n direction here, because this was x direction we have taken, now we are considering this is n direction. So the impact of force in this plate with respect to this one, we can see this is normal now. Now I can consider this is normal actually. Okay, this is normal. Now if you see, if this is normal, that means perpendicular, and this is theta, then what will be, what about this one? This will be 90 minus theta. Okay, and here also same thing. Here also if you see, this is our 90 degree. Then what about this one? Obviously this one will be our 90 minus theta, because here theta. So this is 90 minus theta. Correct. Now what I need to find out here, now we can see this is Fn, the force acting in the normal, in this n direction, that is Fn. Similarly here, what exactly we need to find out? We need to find out the force with respect to x direction in this direction, and the force with respect to y direction, this is y. So that means this is suppose Fy and this is Fx. Now if suppose I want to write here Fx and Fy, then what I'll write here, because already Fn is there with respect to angle 90 minus theta, okay, in the direction of z. So here I can write, this is nothing but Fx equal to, I can write Fn, and this is cos 90 minus theta, because the angle is here theta. So this one I can write cos 90 minus theta is nothing but Fn sin theta. I hope you understand. Now similarly here also same, Fy equal to, if I want to write same thing, I can write Fn in the direction of y. So what I'll get here, this is sin 90 minus theta. Our theta angle is 90 minus theta here. So this is sin 90 minus theta, which is nothing but, we can write this is Fn cos theta. I hope you understand. So this is Fy, this is nothing but Fn sin 90 minus theta, what I've written here. So no need to write again there. Anyway, finally this is our requirement. We need to find out the force exerted by the jet of water in the direction of jet on the inclined plate, okay, which is moving condition. Now this is our requirement, Fn sin theta, Fn cos theta. What about this Fn? Fn also we need to find out in the same way, okay, how we have calculated this formula, mass into acceleration. So in the same way we need to find out now Fn value. So let's find out the Fn here. Okay, so Fn equal to, again I can write the same formula like mass into acceleration and mass flow rate, mass plus yeah, let me write the same thing. I'll write here in terms of n direction. So this is mass flow rate or mass striking per second. Let's consider mass striking per second into the velocity. What about the velocity? Initial velocity I told you. Initial velocity we need to consider in the direction of jet. Sorry, in the direction of n direction. That means I'll write here, this is slight modification I'll do, V1n. That means the initial velocity here, the initial velocity with respect to n direction. This is n direction. So initial velocity, like at starting point, what is the velocity of this V1n? Similarly, here I'll write V2n after striking the plate. What is the final velocity? So This is our requirement. Now we need to find out this. So what about the v1n? So v1n is not given here. So what I'll do here, I'll just take this one to little bit here. Just I'm doing here a small triangle. I'll do it here. Now see, angle you can see there. Okay, and this is our plate. Just I'll draw a small triangle here. Now see, this is our v1n, and this angle, what is the angle of this? This is 90 minus theta. 90 minus theta. Now draw a perpendicular from this to here to the jet, to the impact of jets. Now because we know that this is our v minus u. This is our v minus u. We have seen already this one. This is v minus u, the velocity. This one. You can see the velocity of the jet which strikes the plate. So this is v minus u, and this is 90 minus theta. Now this one, as I have taken, this is our perpendicular, okay, right angle. You can see now this is theta. Now if you want to calculate the value of this one, because I need to find out this value actually. This is v1n. Okay, so to find out this one, what else? This is our, we can write here, this is our base. This is our base, and that angle opposite this one we can take the hypotenuse, and this is our perpendicular here. So now for this diagram, what I can write here, this one, if I write, this is cos theta. What about the theta value? Theta here 90 minus theta. So that is 90 minus theta equal to what? Equal to b by h, the base by hypotenuse. Now base equal to what? Base equal to what? This is the base. Base equal to v1n. Base is nothing but v1n, velocity at the initial condition, like starting and initial condition. And what is the hypotenuse here? Hypotenuse is nothing but v minus u. We can see this is the hypotenuse value, v minus u. So now I can write I can identify v1n. v1n is nothing but this v minus u, take it to this side, v minus u into sine 90 minus theta. What about sine 90 minus theta? That is cos 90 minus theta, that is sine theta. That is sine theta. So we got the value here, v1n equal to v minus u sine theta. Why I am doing this much? Because I need the value of velocity in the n direction, so that I can put the value here directly. So now we can write, this is, see, mass per second, already we have calculated this one. So this is our answer here, nothing but rho a, this is v minus u, bracket start, again v minus n, 1n, what we got here, v, this one, this is one, that is nothing but v minus u into sine theta. What about the value of v2n? v2n is nothing but after striking the jet, or what is the final velocity? This is initial velocity before striking, and this is after striking, the final velocity. So final velocity after striking here, the velocity at this point will be 0. That is 0. So this one. So here what we are getting value actually, Fn equal to, we can write, this is rho a, v minus u we got here. So you can write, this is v minus u square into sine theta. Remaining part, this is 0, so no need to write. So this one we can give in equation, yeah, here we can give an equation 1, and this is equation 2, and these two equations are already there. This one, or else you can give equation 2 here. This is our equation 3. Now we can give this value of equation 4. Now we just put the value of Fn in the Fx, okay, in the Fx. Now we'll see here what the value of Fx will get here. Fx equal to, we can write rho a, you see, v minus u square. Just I'm writing the value of Fn here, v minus u square sine theta into sine theta. This is nothing but, can write, this is sine square theta. This is our new equation. The force exerted by the jet of water on an inclined plate in the direction of jet. And similarly also you can find out the Fy equal to, similarly same thing, rho a p minus u square. What was there initially here? This is cos theta here. So here we'll get sine theta into cos theta. Here we'll get sine theta into cos theta. This is our equation number 6. Okay. Now finally this is our answer actually. This is nothing but, this is our required answer. Now, though you can see here, when the plate was stationary condition, that is different case. Now, when the plate is moving, that means after striking the jet here to the plate, the plate started moving. So there is some like there is a movement happened in this. That means some distance moved by the plate. Okay, that means we need to find out some work done happened. So here again, one more point we need to find out. This is nothing but work done per second. Work done per second we need to find out. Work done per second by the jet on the plate. This is common. By the jet on the plate. This is nothing but, we know that work done equal to, we can write the force exerted on the plate in the x direction into distance traveled actually. But here the distance traveled we don't know. So what I'll do, per second I have taken, that's why work done per second. Okay, so distance with respect to time, per second time. So that is nothing but u. That is nothing but the velocity u. So here fx equal to what we got here. So we can write it rho a. This is v minus u square into sine square theta into u. This much. So this is nothing but, we can write this is Newton meter per second, because force is Newton and this is velocity is meter per second. So this is our work done. Similarly, from here also we can find out the power required. You can convert in terms of watt or kilowatt, you can convert it, and finally also you can calculate the efficiency also, what is the output and what is the input. So this is our output work. Input, what is the kinetic energy applied in that. So these are the applications are there in the direct, these jet applications are there mostly in the turbine case. Mostly in the turbine case, applications will be there. So I hope you understand this problem. Still, if you're having any kind of doubt and query regarding this, you can give a comment on the comment box. Thank you.